Here I have a table of data that was collected for a study. We have 3 columns, one for each quantitative variable that was recorded. First, I'll go through the interpretation of the box plot, and then I'll explain step by step how to draw the graph. So here we're going to show how to draw and interpret box plots. A box plot is another graphical method for quantitative variables. So this is what the box plot of our data will look like. In our study, we took 10 students and recorded their marks in Maths, English and Irish exams. Box plots can be used to display only one variable or can also be used to plot multiple variables on the same plot for comparisons. First, I'll go through all the different information that we can take from a box plot. The first thing is that the center horizontal line of our box plot is the median value. If we go back to our diagram, we can see that this is our center line that is showing the median value of English on the y-axis. The next thing we note is that the top horizontal line is showing the upper quartile value. On our graph, our upper quartile value for English is shown on the y-axis by our top line here. Similarly, the bottom horizontal line is showing the lower quartile value. Again, going back to our graph, we can see that the lower quartile value for English is shown on the y-axis by our bottom line here. The shaded box in our graph represents the middle 50% of our data. In our graph, each of our variables has a box. Again, for English, the shaded box that we have here is showing on the y-axis the range of the middle 50% of our English marks. The whiskers of each box go to the max or min value excluding any outlier values that may be present. For English, the whiskers from our box show that our minimum mark is 43 and our maximum mark is 90. In Maths, we can see that the lower whisker goes to 41, which is the minimum value excluding the outlier. The last point we'll make is that box plots will show any outlier values and they will usually be denoted by a star symbol. An outlier is an observation that does not appear to follow the pattern of the rest of the data. This concept will be explained in more detail later. In our graph, we can see that for Maths there is a star symbol which indicates to us that this is an outlier value that does not follow the pattern of the rest of the data. So here we have our marks for Maths ordered from lowest to highest. The first thing we need to be aware of is how to classify one of our observations as an outlier. If our observation is greater than our upper quartile plus 1.5 times our interquartile range, or is lower than our lower quartile minus 1.5 times our interquartile range, then our value will be denoted as an outlier. In order to classify any of our observations as outliers, we need to work out a few other calculations first. We'll start off with the median. Since we have an even number of observations, we have no individual center value, so what we do is take our 2 center values, add them together and divide by 2. This gives us a median value of 56.5. We can use this for drawing our diagram as the middle line of our box is located at the median value on our y-axis. Next, we need to find the upper quartile. We find this by taking all the values greater than or equal to our median and finding the median of these. We can see our upper quartile is 64, and this is where the top line of our box will be drawn from. Our lower quartile is the median of all the values less than or equal to our median, and this works out as 50. So now we know the bottom line of our box will be located at 50 on the y-axis. From this we can find our interquartile range, which is just our upper quartile minus our lower quartile to give an answer of 14. Now we can work out the range of values that we will use to classify any observations as outliers. First, we take our upper quartile value of 64 and add 1.5 times our interquartile range of 14. This gives us an answer of 85, which means that if any of our Maths marks are greater than 85, then these values will be classed as outliers. Next, we take our lower quartile value of 50 and subtract 1.5 times our interquartile range of 14 to give an answer of 29. This means that if any of our maths grades are lower than 29, then they too will be classed as outliers. In general, if any of our values lie outside this range, then they will be determined to be outliers. If we go back to our ordered maths marks, we can see that 11 lies outside the range, meaning that it will be denoted as an outlier in our graph by a star symbol. The tails of our boxes do not include outlier values, so the tails in this case will range from 41 to 76 on the y-axis. To summarise, in our box plot of English, Irish and Maths exams, the centre horizontal line for Maths will be at 56.5 on the y-axis. Our upper quartile denotes the top horizontal line of our box, and this will be located at 64 on the y-axis. Our lower quartile is denoted by the bottom horizontal line of our box, and this will be drawn at 50 on the y-axis. The shaded region between the upper and lower quartile lines will represent the middle 50% of our maths grades, which is our interquartile range. The whiskers of our box for maths will range from 41 to 76 on the y-axis. The observation at point 11 will be denoted by a star in line with our whiskers, as it was classed as an outlier value. The development of these resources was supported by the NDLR and the Department of Mathematics and Statistics at NUI Maynooth, and they will be available from the following websites.